practice manager over our Java practice here at STG. And he's going to be presenting to you, and I'm sure he'll introduce us a little bit more, but microservices and Docker today. So we're going to have a discussion on that. And we have also up here Brian Hansen, who is our practice director, essentially our version of a CTO here at Software Technology Group. So he has a lot of knowledge as well, and he'll be helping with this presentation. So
there's chairs up front here.
Yeah. So without further ado, I'll turn the time over to Steve, and we will try to respect your time and keep this very strict on the time frame as far as to an hour. And if you have questions and things after, I'm sure we'll have a question and answer session at the end as well as during the presentation. And you're welcome to come up and talk to any of us after as well. So, Steve.
Thank you. So it's my pleasure to be here today and hopefully convey some kind of information that you may or may not have known, or at least raise the issues. Wise man once told me repetition brings conviction, and so if you already heard it, it never hurts to hear it again, because that's how we learn those kind of things. But like I said, my name's Steve Franson. I'm the Java practice manager here. I've been with STG about 8 years. Been a software developer for going on 20 years. Most of that has been in Java Enterprise application development. So that's kind of where I'm coming from. So that's my background. So what I'd like to share with you today is microservices and Docker. Now, don't get confused. There are not requirements for one or the other, right? You can only do microservices with Docker or Docker to accomplish microservices, but they are complementary technologies. So, so with that, just get started. So, in my many years as a developer, you know, I spent about 11, 12 years as a consultant, and I've experienced quite a few different environments. And a problem that I've seen many times is we've got this big, huge system that we are tasked as developers to develop, right? We got business needs for whatever they are, healthcare, financial, real estate, all the different verticals, you know, in businesses. Typically, they want we have this one big system that we need to accomplish all of our goals. But one of the challenges that we have, especially nowadays, is that we have so many different clients, you know, desktop, all of these types of things. IoT, let's just wait until that really, you know, picks up speed, you know, millions and billions of things, but they all need some kind of, we want them to interact with our systems, right? That's our goal, is to have people use our systems and to provide value for our customers and you know, for society in whole, whatever it is. So so that's our problem, and it appears pretty simple on the surface, right? You got a system, just give me, you know, an API, let's just do that, throw that out there, and we're good to go, right? Now, any of you that's ever been, I'm assuming most of you have been associated with software development for a while. It's a lot harder than it appears. It's a complex problem, okay? How do we do this? How do we deal with all these different peoples, all the users and all their things, right? And so what we typically do, or a very common practice, is to develop what we call monolith. Now, you know, hopefully I'm not saying that all monoliths are smiley poo and all microservices are small little smiley poos, but that's kind of the difference, right? I don't know. Granted, I've worked on some systems that are it's an apt description of them, but what we call a monolith, right? And what this means is all of our system is in one application. All of our services and things that we've got, all of the integrations that we do are part of one deployable application, or multiple of these, right? They have tend to have a really large code base that's really complex. Sometimes we run into large redeploys that can take weekends in some cases, or hours in others. We have sometimes they have high overhead, and you know, a lot of VMs, a lot of memory, a lot of resources that are associated with them. a high process of bureaucracy where in order to get one change, you have to go through this 3-hour change process to get sign-offs and stuff. And that's okay, depending on your vertical. Some industries require much more stricter regulations, and you have to do those kinds of things. That's fine, but oftentimes we get to this point where it can be kind of crippling. So we have other typical things that come with it are tight coupling. You can't change one part of the system without redeploying the whole system, right? So it's like you want to change a wall in a house and you have to rebuild the whole house, okay? So we have issues with maintenance. The larger these things get, the harder they are to maintain. People get afraid to change one part because they don't want to break this part because they don't know and understand that part. And so they start doing, that kind of thing where they don't want to touch anything. They don't want to deploy anything new, anything else. And it's inflexible. Sometimes we get to the point where our application just isn't servicing the needs of our clients. We can't do things fast enough. We can't make changes fast enough because of these issues and a plethora of other issues, right? Each system is different. So we talk about this thing called microservices, and we ask, what is a microservice? And tongue in cheek, anything that's not a monolith, right? It's a very broad kind of definition or term, is that anything that is small in nature, right? And talk about that. So really what microservices is it's more of an architectural style. So this is how you build your system. This is how you assemble all the different parts, how you build them, how you put them all together, how they communicate, all these kinds of things. They call it the evolution of SOA, or service-oriented architecture. Really, what we're talking about is distributed systems. It's a known paradigm for decades, and there's a lot of industry knowledge about how to do distributed systems, and we consider it an evolution, if you will. There's a lot of buzzwords around microservices and how they're going to save your company and those kind of things, and we'll talk about that as well. But it really is just a service-oriented architecture. So one of the main goals is the system composition. We have all these different parts of our system that interact with each other. Now, anybody who has ever dealt with a service-oriented architecture before knows that they're kind of tough. They're complex. They're big. But they have certain goals that we try to accomplish. In this context, when I talk about micro, I'm not talking about a 1 or 2 line script that we put out and call it a microservice, right? Talking a little bit more sophisticated, a lot more thought that goes into it. But micro, I'm defining as discrete. And that just means that its responsibility is limited. It does one thing, does it well, those kinds of things. A service is an application, and so each one of these services is a full-fledged application. It's part of your software development lifecycle. It gets, it's a first-class citizen in that respect. It gets all the testing and, process management that we do with it, all those kind of things. But it is limited in its scope of responsibility. Oftentimes, even in SOAs, that we have these big services that are huge and are really tough to manage, right? That they still are big. It's more of we're orchestrating things between a bunch of big monoliths, right? And so they still have the same kinds of things. And so this architectural style is kind of built around being more flexible or responsive to things. And so, and in my definition, I call each of these microservices isolated, that they don't really trickle over into things. So oftentimes we make a change, and I talked about a change in this part of the code over here that affects this completely unrelated or seemingly unrelated thing, and we don't know, right? And so yeah. And again, just as a reminder, as I go on, if I say anything that you have a question about, or you have a comment or pertinent experience, if you've experienced this, please share it with us. I don't want to just get up here and have a snooze fest. And I got a lot of bullet points to get through, but I don't have to get through all of them, right? This is kind of just a side-by-side illustration of what we're talking about. So we usually have a user interface, business logic, data access layer. That's a monolith in the sense, and it can be in the same application package or whatever, right? In the Java world, it's a WAR file. In .NET, I believe it's a DLL, or I don't know. I'm not a .NET guy, but that's the idea. All of your code, all of your services resides together in the same process, uses the same resources as far as memory and those kind of things. So what we're talking about with the microservices is that we start to break those up. And so if you think about, so a common example is an inventory system. You've got an inventory scheduling system. You've got the customer system, the user system that deals with all those things. Typically, we have all those together. They're, you know, an object-oriented world. We have classes that represent those that have all the business logic, but they're all together, right? But here we break them apart. One thing to point out is, you know, the idea is that if they interact with the data store, that they're separated. They're in charge of that. Has anybody here ever experienced where you deploy an application and other applications are making direct calls to your database and it really messes you up? You can admit it. You don't have to say it's where it's worked, where you're working at now, right? So I've heard experiences of things such as production data going into a test environment because of some configuration thing. We've had one system over here that was going off of a false assumption of what the data was, and it was messing up somebody else's data that they really had nothing, you know, to do with. So our primary goals, the first one, I put these in sort of my own kind of priority here. One of the things that I've experienced most in my career is this problem with independent deployability, that we everything is dependent on whatever, right? So we have this process where bug comes in, developer fixes it, checks it in, merges into master or whatever source control you use. Has to have a buy-off from the manager, you know, from their development manager, from the QA manager, from the VP, from all these things, right? Goes and is completely retested, regression tested. It takes hours to get those, and all for one bug, right? I mean, if I was to put on my strict QA hat, that any change has to be regressed, right? And you know, just to make sure that we didn't break everything else, right? So one of the goals here is that accompanied with the solid programming principles of single responsibility, but one reason to change. Off the top of my head, I can't remember that particular one. Open-close principle, right? Where there's only one reason for something to change. And why should your customer system change because you had to make a tweak to your inventory tracking system? Why that necessitates a change to, you know, a whole testing cycle? Again, this is strict QA hat. Why would we do that?
One of the biggest cases I ran into with that with a client was they had rolled out a new, it was part of the central authentication server. They rolled out an identity management system. And we had 3 applications over here that were all deployed, all running independently, doing their thing, but they were using the central service to pull back information. And they said, hey, by the way, next Sunday, your application's going to go down for 4 hours. Well, why? Well, we have to roll out a new version of this. And by the way, you have to redeploy your application because there's, at the time we were using SOAP services with RPC. You need to regenerate new stubs and skeletons with your code, repackage your code back up, and redeploy it. And I went, okay, is this a one-time thing, or is this going to be an ongoing deal? And they said, oh, every time we roll out new features, we're going to have to do this. So if you're telling me there's 5, 6, 10, 12, 15 applications that are out there using this, we're going to bring the whole enterprise down for multiple hours, make them all redeploy, and push this all back out. And by the way, we're going to do this all Sunday afternoon from 5 p.m. until we finish. No.
Yeah. So that's an example of API integrity, right?
Yes.
Why should somebody else really change? If your API doesn't change, why should somebody else really have to do that? Which goes into API things. Sorry, what was that? Unit testing, it shouldn't affect it at all. Independent deployability, I mean, unit tests should be at the level where they're isolated. You've got that. So regression testing, load testing, those kinds of things could be affected. Absolutely, yeah. Yeah, that's where you move up into integration tests and system tests, those kind of things. Right. Well, that should be a layer that you have. So you have code specific unit tests, but also microservice integration tests where it's fully hooked up. If it has a data store, if it's talking to brokers or whatever, that you have those set of tests there, right? And so the point is that you're able to make a change and affect a change to that service and be reasonably confident that that's not going to break anything else. It's going to behave how we expected, but you don't have to test the rest of the system.
So you wouldn't run your unit tests against change at the microservice level.
Right, because you're isolated, right? Your code isn't talking to, well, it may talk to another service, right? But we talk about inter-service communication, but it's not directly related to it in that sense. So that's where the isolation comes from.
So see, he's talking about unit tests. Would you run a regression? Would you have to run a regression test over the whole system?
For that service.
Just for that service?
For that service, and you could do a system-wide test, as it's always good to know if it really does, typically if you do run a regression test of your service and it passes, but then when you deploy it into production and it starts to break things, that means your regression tests for that service aren't adequate, right? And so but that's a general thing that can be said about any.
And a little bit of a sidebar, but for me personally, one of the things I'll try to help companies do when we're changing up their QA practices is if you bring me a bug, I want a regression test that validates that bug is actually fixed and not going to be reintroduced back into the system. I can't tell you how many clients that we work with that go to a manual test and don't actually go put any regression testing in to verify that that's not going to get reintroduced. So when you're getting those bugs or they're coming back, I encourage QA practices to go through and build me a regression test. At that point, as a developer, I can go through and say, this is done because I can run that test and it passes.
Good. So some of the other goals, scalability, what that means is you have a certain part of your system that is underperforming. Your order processing fulfillment system, whatever that means, is slammed, super slammed. That's where all the traffic's going through. You can scale with the monolith and just have multiple instances of the monolith and just route things to only for that part of the system. But that's one of the ideas is that you'll be able to scale this to according to need quickly. Is one of the goals. We talked about isolation with the data store, but also fault tolerance is that when parts of your system go down, that you've architected it such that it won't affect the whole system. Maintainability. So we talked about isolation of code. That the idea is that you limit the scope of what that service is doing. That somebody, a developer can come in and quickly have comprehension of what that service does. By the code, it's simple. It's related to one thing. They don't have to understand how it interacts with everything else, because that really should be some other systems problem. But I will caution you with this. Sometimes you can get into the problem of scope paralysis. I don't know if a really good term. What you really need is a person or a group of people who understand as much as possible the bigger picture of the system, because you can kind of get lost. We talk about small services, and that's what we're talking about. That somebody can start to lose perspective, don't know that there's actually a service that does the exact same thing that you need it to do. It's just, we'll talk about, the scale of what we're talking about is you could take a single monolith and break it into dozens, if not hundreds of microservices. It's a possibility. It depends on your system, on your needs, what your team is willing to do. But when we're talking about that many, we're talking about the really applications that can get difficult to manage if you don't control it from the outset. So lower overhead, deployment process. We're talking about, I want to deploy this, right? this is one service. It has a bug fix that we're done. We fixed it. We want to go. It's not necessary. If everything, in an ideal world, right? If everything's there, you don't need to consult all the other services and all the other teams that control those services, because you've done your due diligence. You've got it there. The process should be quicker. Now, this next one, technology or language agnostic. That's one of the goals that people commonly put in, but the consultant in me is kind of balks at that, just because you get too many of these little services, and you've got a Python script that's running this, Node.js one over here, .NET application that's doing something over here, Java, Go, Erlang, who knows what it is. So the issue is be cautious if you go down this route with a polyglot kind of system. As far as languages go, it's who's going to maintain all those things. That person who put that service in place, okay, well, what if they go to another team, another company, hit by a bus? So my advice is to stick with your core languages, make them as uniform as possible. If you're a Java shop, then stay as a Java shop. .NET. But one of the side benefits of this is if you feel it's necessary, you can implement something else in a different language. For whatever reason, it does scale better than the stuff that you're using, those kind of things, but I would limit those kinds of things just for the management of resources and those kinds of things. I would limit the polyglot part of it to be other services, like third-party services that you use. That would be the primary thing of that. You've got a server that you need to deploy for whatever thing that it's going to deploy, and it's in a different language. So keep it to those. Let it be its own thing, right? So any questions so far? Anybody chafing wait a second, that doesn't make sense? Okay.
How does this differ from an ESB?
So an ESB itself, so we're just talking about an enterprise service bus, that can actually be part of the system. So that's typically an ESB is used to route services through, from the outside and go to other places, do routing, can do some simple transformations and those kinds of things. That's actually a good tool that could go as part of the whole architecture. But it's not necessarily, it's not really a comparison. One's an architectural pattern, one is a implementation pattern.
Sure.
So
do you feel like a microservice that calls other microservices is a good idea?
It can be. It can be. That's and again, it depends on the scope, on the needs that you got. We talk about, and so what he's getting at is there's two general flavors of these kinds of architectures. Now you can have both of these, all of these other ones that I don't mention. One is a point-to-point, where one service says, I need some information from this other service. We talk about service registration and discovery. So just like phone book kind of thing. Hey, I need a plumber. Okay, so I go and Google it nowadays. But we go and look it up. Here's a plumber. Okay, here's their contact information. And then I go and contact them and list their services. So, but we have to know that plumber has to make sure that they're, people can find them, right? And so they register with these. But typically we're talking about kind of a procedure call, remote procedure call style. This service does the registration and the discovery and then talks directly to that service. Typically over agnostic technologies like HTTP, REST, SOAP, those kinds of things. And then we have an event-driven system, which is, message-oriented middleware. That's a well-known pattern as well, where it's all events, right? We come into a common gateway that initiates a response sends things through a set of queues that go through all these services. They all talk asynchronously, some cases synchronously to each other, and it comes back to received and sent back out to the client. Those involve event streams. If some of the developers have heard of Kafka, that's one of the newer, sexier things that involves event streams. Well, when we talk about web scale, that is a good architectural pattern to adopt because it's asynchronous and you can scale things up and there's not a lot of state. One of the common practices one of the temptations with monoliths is that it has stateful something. That this client knows all this stuff and the server knows all this information about that one client, and they can't do what else it needs to without all that information. So when we go to an event-driven, they're just like, hey, I just need this information. I'm trusting whoever's sending the request that it's all internal to your system. They don't need all that context. It's not necessary for that, but that's a different architectural style. So here's the big question a lot of people have is when or do I implement microservices? And this is something that every individual team should ask. I don't think that microservices solves every single problem. There are a lot of cases where a monolith is perfectly acceptable. That you're depending on the scope of what you're trying to do and those kinds of things. Because in one respect, you're going to trade a different set of problems with a monolith with microservices applications. So, but some of the red flags that may get you to think about whether or not it's time to start implementing a microservice architecture are all these things. Scaling, all those kinds of things. I'll just read them because you can see recurrent deploy issues, fragile configuration, scaling or performance issues, flexibility. And the last one I think is a key. When we talk about a microservice architecture, we're talking about many, many different applications. And so if your team doesn't do one application well, the likelihood of it doing many applications well kind of goes down, right? And so when your team is ready to commit to it, and this is the reason I'm a big advocate for standards, for continuing education, for all these best practices, adopt those, live them religiously, if you will, ingrain those into your team culture. Because if your team is undisciplined, going to a microservices architecture could just make it worse, right? And so I would caution you against that. Also, you need to have buy-off from management. That why are you doing this? You've got an application that works. If you're moving from a monolith, why are you doing that to get it there? Again, you have to present that business case to them and have their buy-off, right? Because it's not necessarily going to get easier with a monolith.
You can trade one technical debt for another technical.
Yes, you can. Yeah. But again, some of the goals are there to reduce the scope of that technical debt so you can attack them easier. Right, just like you refactor code when you don't understand it or it's causing problems and it's just too difficult to maintain. You break it out, make it smaller, use other patterns to help with that. So now there's again, don't get me wrong. The challenges that I'm going to present to you are common to every software application, but more so with any service-oriented architecture. Right? And so I present them here just as things that you should think about if you decide to adopt these. Complexity. I talked about hundreds, if not thousands, of microservices. That's a lot to deal with, both conceptually, managerially, deployment process for all of these hardware, for all of these things, all that kind of stuff. Inter-service communication. We talked about point-to-point, event-driven kinds of things. You're going to have to think about that and architect around it. Latency, we talk about you're not necessarily going to get faster with the microservices architecture because you're talking multiple thousands of services that need to talk over to the network, and there's time involved with that. Serializing and marshaling and unmarshaling messages takes time. So there's some of those issues that you'd have to address. There are patterns for addressing those. Caching is one thing they call experience services where it does the caching and those kind of things and cut things down. Data consistency. We talk about this service over here has a dependency on other data, and what happens when this piece of data over here goes away or is changed? How does this one know about it? So you have to deal with that issue. You know, again, one is, you know, a pattern is called a Saga or a Saga pattern. You know, they publish something on a topic that this guy picks up, says, oh, they send a delete message, I need to delete it. My data is no longer valid. So those kind of things. Distributed transactions is a difficult problem in any system. When you're talking about the dependency of something to be effective here, has to talk to all these other things, and if something down the line breaks or fails, we got to roll it all back, and we don't keep all that state. That's a tough problem in any system. So more so if you're talking through 100 different services. So again, there are patterns to help deal with that. One of those is, hey, do you really need an actual transaction? That's a big question, you know. And then versioning, we talk about API consistency and how do you roll out changes to versions of things, right? How do you deal with that? How do you route things in with these new services and your API breaks? Again, a common problem, especially if you're library development or those kind of things. You've exposed a third-party API. How do you version that sensibly and not break everything? Yeah.
Sorry, back to the data consistency. So if you're going from monolith to database, a lot of times you're straight to your order ID over here. And that's forced through a constraint on the database potentially. You do a microservice that enforcement code or something all from the data layer.
Yeah, you could. I mean, there's all kinds of things. Depends on the data store, whether they can do those consistencies. You know, you've got distributed syncing. The term escapes me. Where this replication, you've got those kinds of things at that layer that you can do. But also, you know, think about a UUID, for instance. You know, that you got a reference to that over here, and really, this one never ever really talks directly to that one. He just sends a message out onto a topic, says, hey, I need this. Boom. Okay, and somebody sends a response. That's one way of dealing with it, but that's the problem there. And so you'll have to address that if you can't solve it with your database tools or your data store tools. So good question. Yeah.
So as you talk about migrating from monolith to services, it starts to bring up go from one call to two calls, from dozens of calls. Then you talk about that communication between services themselves. Implementing tools like API gateways. Does that fix the issue, or is that
I'm not a believer in simple fixes for anything, or we're talking a complex system. But yeah, API gateway is a good pattern for being able to manage some of those. What he's talking about is that you have one service that acts as the gateway for all these APIs. And so you can abstract it to where you've got all these services back here that from the outside it looks like one, and then you can kind of change things on the back end and those kind of things. And so that's one application of that pattern anyway, but it can make it easier. Sorry, I kind of lost my train of thought. What was the question again? Did that answer your question?
talk about that problem, intercommunication with several different microservices and energy?
Right. Oh, okay.
Gateway.
Right.
All that, or is it just-
Yeah, and so I mentioned a pattern called an experience service or a view service, if you will. That you can have other services that to say that need data. Your front end needs data from 5 different of these services back there. That service can act as the coordinator, right? It makes all 5 calls, come back, a broker, an aggregator, if you will. Whatever some of those integration patterns, they come back and they can formulate it into a sensible thing. So one great example is who here uses Netflix or some kind of streaming service, right? So actually those services, a common architectural pattern is microservices, right? You think of how many different clients that they need to accommodate. You got Android, iOS, smart TVs, Kindles, Rokus, all those that may have different requirements, that something that they can't get the streaming to work right, and so they need to tweak something, whether it's metadata that they send or retrieve, that they have these things called, these intermediate services that can translate, transform requests, do things that, for specific for that experience. And so you can adopt one of those patterns to help. And that's where you can cache at that level that that's going to happen, whatever. You don't need to keep going back and forth for stuff that's high usage, those kind of things. So anyway, so great questions though. Again, we talked about service registration and discovery, configuration, cluster management. How are you going to deal with all of these? One of the things is, how do you know all these services are running and they're happy and healthy and working, right? Some of the DevOps people in here probably know that's a familiar problem. It doesn't really change. It may change in scale because we're talking about thousands of applications possibly. And then when something goes wrong, how do you find out what's going wrong? That we're talking, this cluster over here of your service that's throwing some errors. Which one is it? Where is it going? And that's a lot of information that those applications are producing. How do you aggregate all that logging and find it out and search through it and resolve, to track things down? Again, I want to kind of skip through a lot of these real quickly. We talk about how do you build these things? How do you deploy them? What is the mechanics of a developer going from code on a developer's workstation up through a deployed application? Those are going to be some of those changes that you do. Testing, we mentioned testing is going to be a challenge. And again, the last two is training. That developers, you're going to have to write code different in a microservice architecture. You're just going to have to. Because you don't have that tight coupling that, making another method call isn't going to cut it. That you're going to have to do it full tolerance. What if that service goes down? You're in the middle of a request and it goes down. You don't get a response. What do you do in that case? Not so much a problem in a monolith, right? Because you just throw an exception and you're on your way, right? But developer training, training the management of project management, of dealing with all these things is going to be crucial to that as well as making this part of your culture. That would be my recommendation, is that you change your culture to be, again, much more disciplined, much more, adopt best practices, unit tests of all kinds, that those are mandatory. Because when you get to that scale and so many things, that complexity is going to be hard to manage. But this is one of the common patterns that people use for continuous deployment, is that they write code, check it into a branch, they go and do a code review, everything, all their tests are green, they commit it and merge it into master or whatever that process is. As soon as it's gone in, it builds, does its own tests, automated tests, and then goes out to production. We're not going to a test environment. We're not doing that. These kinds of things facilitate that, right? And so that's what a lot of those continuous deployment shops do. So now, one of the problems is, how do we actually do this, right? We're talking whoever is installed like an IIS server or a Tomcat server or Node server, any of those, right? How many of you have done all of those? Okay, what was it easy? Kind of a silly question, huh? Not at first, okay. But do you want to do that every time that you have to do some system?
We actually had that conversation. Depends. I am old school of the opinion that if you're going to develop and you want to be able to know what's going on, you should be able to set up. And that's me. So I would prefer to have a local setup, not set up batch scripts to help someone else configure the company.
Okay.
So yes, I would rather do that.
Okay. What is the scope of the knowledge that you had to have about all those systems in order to get them set up? 20 years experience, right? Okay, not to trivialize your accomplishments.
He has to work for Star Laboratories.
Right. Okay. Yeah, comic book nerds. It's great. I think I know which one I'm talking about, but DC Comics, yeah, I know. Gosh. How about if I was to tell you that you could set up an environment in minutes rather than hours or days?
I would believe you if the first time I tried it.
Okay, well, that's a simple fix. Just give more memory on one system. But that's one of the common problems, right? Is so developer provisioning is what I call it. How do you get a new developer starts up? You've got this huge system. Even nowadays, monolith systems that you've got a lot of dependencies. Are you going to expect the developers to know how to install an Oracle server and configure it to match what production is, so that you know some characteristics and settings and stuff? Okay, if you want to waste their time for days, maybe weeks, sure. But one technology that can help with this, it's not a silver bullet, won't solve all your problems, but one of those is Docker. Now, what Docker is it's a container management or a container technology. So we've all heard of VMs, right? Virtual machines. And nowadays we send them up, they're in the cloud, you know, we've got AWS, whatever. Oh, yeah, I got a new application, well, let me spin up another VM, right? Okay, that's all great and all, but what if you got, and your style is that you actually deploy a full VM for every application, right? But what happens when you have 100 different services? And you know, that starts the scaling of that starts to be limiting according to, you know, all those resources. You can only do so many applications running on the same server responding to all of this at the same time before issues like memory and those kind of things come in. So what Docker attempts to do is it's a technology. These concepts, you know, I'll talk more in depth with here in a minute. But so we've got this this kind of diagram. This comes straight from the Docker side, where we talk about with a VM that we've got. It's really this line right here, where you have a guest OS on every single one of those virtual machines. Every operating system incurs some kind of overhead. You've got all the stuff that it does to do its job. And then on top of that, you've got an application on top of it, right? What the container does in simple terms, there's a lot more to go into this kind of thing, is that it shares all the operating system resources, and it uses you know, kernel level things. It's built off of a Linux technology, but is applied to Windows and whatever, so you can have all across those systems. But then it shares a lot of those resources, and those contentious resources that are managed by the OS, it's able to do that for you. Okay, a lot of other stuff there as well. So it's a typical host with agents, if you will. Each of these containers are called agents, or can be thought of as agents. That you've got that host on the operating system, and then all of those containers that kind of fit on top of there. So a Docker image. So here's the key to this whole concept. People get confused between a Docker image and a Docker container. A container image is a lightweight, standalone, executable package of a piece of software that includes everything needed to run it: code, runtime, system tools, system libraries, and settings. So experience that I've had is I've got to provision a new server. I got to put a Tomcat server on there. I got to get it all configured and everything else. I've got to start up that app. I've got to do all that stuff. And that's just to get the server set up. And then I need to put all the application code on there and get those. If there's multiple applications, I got to get them all working together. An image, a Docker image, when we talk about, it fits nicely with the concept of a microservice, is that an image represents what you will deploy. So it's not the actual running instance of it. So you think about, in a car analogy, that an image is a make and model of a car. And then you've actually got, so you've got what it's going to look like, all the characteristics for all of those things, and then you've got the actual car. And the container is the actual car. It's the thing that's going to physically you get in and drive around it. But a model represents all the features and everything. All the performance characteristics are defined there. That's one analogy of it. So, a container is a running instance of an application. Here we go. So some of the benefits of Docker: resource sharing. We talked about the OS sharing. Standardization. Again, all those DevOps. That example of deploying all those different servers on those servers, or all the different application servers on all of those hardware servers, you needed to know all the commands to install Node, and you need to know all the commands to install, PHP and Apache and all those different things, right? Well, and to get the ports so it routes to ports right and all that kind of stuff. Standardization with Docker, you have a limited set of commands that does all of that for you. It's the same for whichever application that you use. And so containers, images are all built the same. Containers are all built the same. Containers are managed all of this in the same ways, those kind of things. Custom images, you have a particular a set of systems that your code relies on that you can go and say, oh, you know what, I need to have this configuration because this database doesn't work for us right unless we have this configuration. You can do an image of that, and then a developer can pull that image and create a container on their machine that has that same configuration. But you can do custom things according to that. We talked about isolation in the sense of network isolation, resources isolation. They're not going to clobber each other if something goes wrong. Like in the Java world, we have two wars deployed in the same container. This war starts to misbehave, has a huge memory leak, it brings down this other application. And so now you got two host applications instead of just one. So the Docker containers in that sense are isolated. They won't do that. And that lends itself to clustering. So, again, resource sharing, small portable images, you can move them around relatively easy. Faster startups. Who here has had a SQL Server start up in less than 30 seconds? Not very common. I'm not even a Microsoft guy, but every time I've done it, it takes a little while, right? Some of those things, they come up very quick because they're not building on the whole application, the whole operating system, those kind of things. So
Steve, one question for you, and you may touch on this later, but as we're talking about microservices, one of the hiccups I've always seen with microservices is versioning. Docker container, do I run 2 instances of the same service if I've changed that contract? 3, 4? What's your experience there?
You can. So they actually have a servicing or a versioning built into the whole technology. And so you can actually, if you model your application to an image, so this is this version of this application, that you can tag things by that particular version. And so yes, you can have multiple versions of the same application concurrently. It's probably not recommended because but it's possible, right? And then you've got other strategies to route according to URLs and all kinds of things to go to the other, to the right one. But you can version them, right? But it's the same, right? An image of this one, it's going to have those changes, but how you deploy it's going to be the same, right? And so very easy to manage, or easier to manage those things.
I would say that's a number one problem I see with clients that run into a microservices architecture is running multiple versions. And like Steve said, I don't recommend running more than 2 at a time, but I have seen instances where we've got all of this code that we haven't migrated to this new service that we've done, changes we've made to the service. We need to keep that up and running, but we have this new service that we rolled out. We want to start developing new applications against that. We can't go rewrite our entire code base at once and roll that out. So I can run those 2 concurrently. I don't do something like Docker. I've got 2 different wars deployed, or I've got 2 different app servers set up, web servers set up. I go run through these weird hurdles to get it up and running, where I can just have 2 versions of Docker instances, and all of that's taken care of.
Okay. Yeah. So you still have the problem of multiples of things.
Oh yeah.
But Docker makes it easier because you have the images, they're built the same way, they're deployed the same way. Then you get down into the individual configuration may be different, but yeah. So I want to kind of breeze through a couple of these. I do have a demo of a microservice using Docker, but again, we talk about custom images. Licensing is another thing. You have a particular license that you don't want to share with all your developers. You can create a custom image that has that license installed. They can run it on their machine. That's one thing. Actually, one thing I want to touch on the standardization is environments. talked about developer provisioning. You can get a developer started in a matter of minutes instead of days. As far as setting up their servers, and you've got a mail server and a application server, a database server, all those kinds of things.
I would say that's the #1 misconception I see with new developers starting to use Docker. Great, now I gotta go learn Docker. You don't need to know anything about Docker for me to go provision you an environment. Is it good for you to know, to go back to your question, is it good for me to know what goes into that Docker instance? Sure is, but if I hire you tomorrow and I want you to be productive in my environment, you can start using Docker instances right now without knowing anything that's going on in that Docker instance. You can learn how that's configured as you go, but you can spin that environment up right now and get working. And I see developers all the time go, I've never used Docker, and now I got to go learn Docker. No, you don't.
Yeah, you don't. Have it installed. I can give you a command to set up, all the a message broker, and we'll see that in a minute. A database server, all those kinds of things with one command, right? Another one is being able to get closer to the production environment that you deploy them in production. Use the same scripts and the same things to get those to running in there. I've used it to have different branches. Different databases for different branches. I can bring them up, create a new container to run my code against one branch and shut that one down and go to another branch, those kind of things. Testing, you have applications in testing to bring up an environment to do your integration tests against. Operations, all kinds of different applications of this. So let's see. We'll talk about some of this. I'm obviously going to skip across. There's lots of support. It's gaining much more adoption into some of the larger platforms and things. AWS, Azure, DigitalOcean, all of those platform as a service have support for Docker. So my Docker demo. So we're going to be a fast one. So the basic idea is that I have a client that talks to over WebSockets to a producer that gets those requests, sends it to a topic. We have an enhancer, essentially application that increments an account, puts it onto another topic that gets picked up by a responder that gives a more full response to it, sends it on another topic that's picked up by that producer, and sends it back out to the over the WebSocket to the client. Okay, so this is an example, a very trivial example of an event-driven architecture. This is all asynchronous in the sense that the producer is not necessarily waiting for an answer to that particular thing. But anyway, so I provided in these slides, and I'll send these slides out. This is the Docker container, or there's a tool with Docker called Docker Compose, which Docker itself deals with the management of the images and the containers. Docker Compose will compose all those together. And so this Docker Compose file is all that it needs in order to set up all of these systems. So the 5 minutes, let's do you guys have any questions before I get into this? And I don't want to go over, but do you have any questions that I haven't addressed yet? Do you want to hear before I do this? Okay. So what we've got here is we've got a producer, a counter, and the data store for the counter that just stores a number. The responder that actually into just a hello, hello world kind of thing. And then all serviced by a RabbitMQ instance. Okay, and so there's some, I don't have time to go into all the details of all this. We got a network that puts them all together, got an isolated network, so nobody else can get into it if you don't want them to, those kind of things. So I won't show you the code. I've got this on GitHub that you can download as well. So some of the Docker commands, let's get this a little bit bigger. So Docker PS shows all of the running Docker containers. In this case, it's a database for one of the projects that I'm working on. So I'll just stop that guy. and I see on my host, my local machine is my host. I see nothing there, but I can see all the ones in the past that I've done. And I see that I've had an image or a container called that. Docker images, I can see all the images that I've already downloaded. So one of the advantages of Docker uses a layered file system. So these images build on each other that you can already have those partial images downloaded onto your machine. You don't have to go out and get them if you reuse them. Right? So one of those is this Alpine Java guy here that I use for my code. Java guy, I'm going to do a Java demo, but here, so we've got, so as I've shown that we've got Docker PS, there's nothing running. And so using a technology called Swarm, which is just kind of a native Docker cluster management stuff. If I could type these right. This is where I knew I was going to do this. Forget all the commands while I do this. And I want to build these things first, just to show you kind of the steps. Oops. I have to call it right. So I'm building the application code. I've got a file called the Docker file. I'll show you here. That defines what my image is going to look like. I've got my base image. These are all the steps that I have to go through. This is scripting this of what this image is going to do and what it's going to contain. It exposes, in some cases, it exposes ports and those kind of things in order to get things to work. So I built it. I'm going to use Docker to build the actual images. Your build can actually do that as part of like a Maven plugin that'll do it, or you can do the same thing. Just all it does is call the Docker on the host to build the image according to that. And so I'm going to add myself to a Swarm instance. It's already part of a Swarm because testing to make sure that I could actually do this earlier. So I've got a host manager on my machine. This is a little limited because it's one instance, but so just to show you localhost, I have nothing running. I'm going to start, or I'm going to create or deploy my stack. So all of those 6 different services that I have, I'm going to start all of those. Right now, I'm going to use that Docker compose file. I'm going to give it a name of Microservices Docker. And I'm going to start it up. And I forgot my network. So, which is this line right here. What this does is basically sets up this isolated network that it can run on, and then I deploy it. And so now it's going each one of those service declarations in that compose file, and it's starting up an instance of that. There's a little thing in there that I put in there to how many nodes or replicas, as they call it, do I want to start. So there's 2 replicas of the responder. And so I've got my producer that's showing up. I'm going to give it a second because it takes a little bit longer to start all these on my same machine. Talk about running out of memory. See if it works. Okay, one of the commands is see the logs. After that. So the responder's running. Let's do the producer. See how that coming up. Okay, there's the producer. Okay, so we've got this real simple hello world. Like I said, talking WebSockets, goes around a bunch of the queues. Usually I don't have enough, or my responders aren't up yet. apparently didn't make the right sacrifices to the demo gods that I should have this morning. Because there's nothing like a live demo that fails, right? Works on my machine.
Worst live demo mistake I ever made.
Let's go.
I think after we started it for months on end. Every day. Somebody said, oh, you need to restart this to have something.
Okay, well, essentially, so in lieu of it not working, I'll just show you that I've started all these things. So in the case of a developer provisioning, that they could have this application running in a matter of minutes. It may have to download a bunch of images and stuff. It's like a lot of builds, you know, NPM downloads all the dependencies and stuff. It's going to download all of the layers, images, those kinds of things. Let's see if give it a little bit of time. See what's going on here.
We hit 1 o'clock.
Yeah.
Want to be during your guys' time and context to that. If you guys want to go, we won't stop you. If you want to wait a second, you can troubleshoot this a little bit. Or if you have any other questions, feel free to hit me up or Steve or whatever. But thank you, everybody. Thank you for coming out. I appreciate it, and I hope this was informative today. So.
Yes, thank you. Of course, I got egg on my face because my demo didn't work.
It's going to be 30 seconds after every.
I know. I'm going to turn around. Oh, I just need a little bit of time. Go ahead.
At what point do you identify, hey, we need to break a application, right? Because when you start down that road, you may have to get back and say, why did we need to be broken when it's already broken? But, for example, one case is you have an API. You have several different things that rely or make calls to the API. The API will clear out. Well, if one of those things is updated, one of the API needs to be updated. So what you're like, how do you
Well, one of the common things that I've encountered, so front end versus back end, right? So nowadays we do single page apps. You've got front end and then back end that has RESTful APIs, right? So one of the times is when you're doing a lot of deploys for the front end, but your API is fairly stable, right? That's one scenario where why redeploy the back end when, you know, and you've got these in a cluster, you know, servicing front end code, servicing these back ends or the API, a lot of those instances. Why redeploy all of those if nothing changes, right? And so that's why we can break those into, you know, a microservice of just the front end code. So that's a scenario. Another one where APIs come into play is, you know, you actually have an API change. The actual functionality of the API doesn't change, or does change, but the API itself doesn't. So that's API stabilization, that your API really isn't changing. It may give some extra information that they may be able to not use, but then you would, in that particular case, that's where we talk about routing to different instances. You can have two of the same until all the clients can move over. You can have a proxy in front of it to be able to manage, you know, through headers or URL matching or all those kinds of, there's different kinds of strategies. But generally, it's when you have difficulty of doing both at the same time and you're doing a lot of one and not of the other. A lot of changes there. That's one indication, right? And that's where you can, and you don't necessarily have to adopt a full microservice architecture in order to accomplish that, right? You can just break your monolith up into those two sections and do that. I would say that, you know, if your API is changing a lot, your API is not, you know, fully, or it's either too big, it's encompassing too many services, or trying to do too much, and that's where you can break them down into things that don't change as much. You know, break those down, and one that's very, very volatile, then you only have to deal with that one, right, and not affect all the rest of those. That's another thing that you could look at.
So my answer is much smaller. If I ever have to avoid something else because of the code change that wasn't tied to it, it's time to rebuild. If I have to go change something else, I have to rebuild, redeploy, anything else other than the unit of code, the vertical of the code that I was working on, it's time to break. And it's a rule of thumb. It's not fast. Oh, you know, that's it. Erase everything. But I worked with a client that we had. They had broke stuff up and they said to break it up. I understand why. Like, they were up to these little micro pieces that talk to the database. Problem was they had circular dependencies on their build. I had to go build the application. It would break. I had to go build the other half of the application. It would break. I had to go back and build the first application again that was successfully built. Yeah, every time I built my code. And there were these dependencies that were just, they were mashed like this. And because I did this one, I now had to go redeploy everything else again. It just gave me a nightmare. We broke it up into a little basic microservices architecture. Had an email service that we could call, and the apps could go out, and we broke it up into a PDF generation, so iText. I had to start including iText libraries in every single app that was deployed because we thought it was an insurance company. Why didn't you have an iText line? You look at the dependencies on an app really quickly and go, what are these 53 jars that I've included in my app? Man,
Service one, service endpoint.
Yeah.
Show me the PDF. Well, great. Oh, okay.
Yeah. So we started breaking stuff up just in small little silos of reuse. Hey, we all use this one. Great. Let's take that little guy out here and shove him out here because he should sit there till the cows come home. It may never move from version 1.0. I have others that have been version 3 or 4 times. And it's just, if I change something and it broke, something else is like removing.